Good morning, everyone. So, what we're going to be working on this morning is learning a little bit about the differences between scientific and normal notation. So, this is just a very plain and simple, dry cut topic and I just want to make sure that you all understand what scientific notation is and how to convert into scientific notation if necessary. I don't think there's many situations where you're going to have to convert back to normal, but it's good to know that as well. So scientific notation is is a way to express a very small or large number into a way that is more understandable to the reader. Now, what that is that, so if we take an example like 0.00000000001, and you're looking at, well, so we know that this is a very, very small number. Now, right now, the way it's written is a normal notation, and that's the way we always write numbers. But every now and then, we need to convert it. So this is a good example of a number that would need to be converted. Now, the the way we do this is that we express it in scientific notation by moving the decimal place to the right of the first whole number. And that's the way it's always going to be, whether it's a big number or a small number. You always move the decimal place to the right of the first whole number. Now, in this example here, we would move the decimal place to here, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 1 times 10 to the minus 10. So when you move the decimal place to the right, you have a negative exponent. When you move the decimal place to the left, you have a positive exponent, and that's what you're seeing the way I'm writing it there. So if I have a number, let's say, I'm just going to use a very simple one, 101. Well, we know the decimal place is here. Even though it's not written in, it's there, all right? And so if we go any further past that, well, we know we're going to get into smaller digits. So again, we're going to move the decimal place to the left, this time 2 places. So that's going to be 1.01 times 10 to the second. So again, we moved it 2 places to the left, to the right of the first whole number, and we use that as our exponent. Now, I've got a few examples we're going to work here just so we can get some practice with this. I'm not going to go back to normal notation because it's not necessary. It's just going backwards from what you do to go to scientific notation. So that's just, all right. So we're going to take this 67. We're going to work these 5 examples here, and so you'll see how we're going to move the decimal place. So hopefully this will clear the issues you might have with it. So this one's going to move to the left to make 6.756, and we moved it 1 time to the left, so it's 10 to the first power. All right. So again, every case, you're moving it to the right of the first whole number, and that's what we did here. So part B here, you're going to go to the right of the number 4 here. So you're going to have 4.0 times 10 to the negative 3, because there's 3 jumps there. All right. Part C here, you'll have 1, 2, 3, 4, 5, 6. So this is 3 times 10 to the negative 6. So notice that this one doesn't have a 0 to the right of the 3, so I don't need to include the 0. But in part B, I do have a 0, so I need to make sure that I include it. These are rules that are going to be explained in significant figures, and so these are just things to make note of right now. Now, when you get into the numbers that don't have decimal places like parts D and E, well, I'm not going to include the zeros because they're not necessary. The zeros are just placeholders that help to show how large or how small these numbers are. So like letter D, the decimal place is not there, so but we know it is there. It's just not written in place. So this would be 2.5 times 10 to the third power. So again, notice that I did not include the zeros because there's no decimal place. We're going to do the exact same thing for letter E. 1, 2, 3, 4, 5. So that's 1 times 10 to the fifth power. So again, if you move the decimal place to the left, you're going to have a positive exponent. If you move it to the right, you're going to have a negative exponent. And then just pay attention to those little subtle details about if you have a decimal place. If a decimal place is present, then the zeros to the right of the first whole number will be written. If there is no decimal place, then the zeros that lead and are to the right, let's see, that are to the right of the first whole number will not be written. All right, so that's just what I want to summarize there, is just paying attention. Those are just subtle details, and the more you practice this, and the better you're going to get with it. So, you guys will have that problem set to work. But for now, that's what I wanted to cover today, is just how you express a number from normal to scientific notation. This is something that you will be utilizing in the future, especially when we get into significant figures and as we progress through the semester. So, all right, thanks. Take care, guys.